The kind of program builds up over the course of 2 weeks. It's 2 one-week modules of training, and it kind of builds up. You start with what's called PSP Level 0, where PSP 0 basically is whatever you normally do. You get to write a program every afternoon of the course. There's lectures in the morning, and in the afternoon, they give you the specification of a program, and you're told, okay, go and implement that program, and there's a minimum set of test cases that the program has to pass. And on day 1 of the course, PSP Level 0, they say, okay, write this program doing whatever you normally do. That's your baseline. To some extent, that's really crucially, that's your control experiment. That's your baseline performance for whatever you normally do. Because if you're going to improve, you have to have something to compare against. So day 1 is your control experiment. The only requirement additionally to that is that you have to measure your effort and your defects, basically, so that we can start with a basic set of metrics to see how we're starting. It then builds up, 2nd, 3rd day, and as it builds up through the course, so we add size estimating to the process. So that's where we start to actually break down a program by decomposition, and you say, well, this is a small bit, this is a big bit. Big bits are 100 lines of code, small bits are 50 lines of code, and then we add the numbers up and we get some basic breakdown and estimating framework in place. We use that to then estimate time. If we can look at our historical productivity, we can say, okay, 500 lines of code, it's going to take something like, I don't know, 5-6 hours to do that or something to the required standard. And we start to do time estimating. Then we go into real task and schedule planning. So this is going into things like earned value analysis, and then actually breaking down, saying, right, I'm going to spend 10% planning, 10% in conceptual design, 20% code, and actually distribute the work over a simple process as you'd expect. And it introduces the concept of earned value tracking as well. The second week introduces the important stuff, bringing in well-managed, well-structured design and code review process through the use of coding standards. One of the activities on the course is you actually have to define your own coding standard. Because obviously you're doing the programming using whatever is your favorite programming language. So you end up having to write your own coding standard and then write a checklist for it, which you are then obliged to use for the rest of the course. So you end up kind of building your own toolkit. It's really, really interesting. And it builds up and builds up. The idea is that you can hopefully see yourself improving. You might think, oh, this all sounds like a lot of work. Well, luckily, almost all of this work is automated with some very clever spreadsheets that the SCI used during the training. So, for instance, logging a defect is simply a matter of you click on a particular worksheet in the Excel spreadsheet and you just say, oh yeah, defect, found it, whatever, this time, boom, boom, oh, it's a syntax error. And things like how long it takes to fix just gets filled in for you. All you have to do is keep an eye on your watch and basically everything else happens. It's a bit unusual that when you're doing this, you do actually have stopwatches running. You have at least two, you normally have 2 stopwatches running. You have one for elapsed time and one for interruptions, because you have an interruption clock running. When someone comes and talks to you or you go for a cup of tea, you don't count that time, so that's on the interruption watch and you knock that off at the end. There's a very smart statistical basis behind the spreadsheet. There's a whole bunch of stuff going on with looking at correlations and deviations and so on in the data set to help you predict your future. So that's all done for you. And it's almost uncanny. By about the 6th or 7th program, I think when I estimated the 8th program, I did a conceptual design, broke it down, estimated the size of all the parts, added them back up again, and it said, my estimate came out at however many lines of code. I put that through my data set. The data set said, well, on average, in the first 7 programs, you've been underestimating by this many %. Therefore, I think it's going to take this long. And well, we'll see, I guess, how I did. But it's really quite surprising how even with a fairly small number of data points, this system learns your behavior and allows you to estimate really quite well. So here's an example of the front sheet of the spreadsheet. This is called the project planning form. So this is for program number 8, when I took my training. This is the plan figures for what I thought it would take to do program number 8. These are the actuals. This is how long it really did take. And this is my cumulative figures for all 8 programs that I'd written during the course of the training. So let's see. My planned time rolled up to 291 minutes. My actual time was 303. So I wish I could estimate all my work that well. I wish I could get everything to be, that tight. And that's about, what, less than 5% or something. So what else can we see here? Things like my planned defect per K-lock injection rate was 27.43. My actual was 19.23, so I did something better than plan. And for the average for the 8 programs, I was injecting slightly more than 24 defects per K-lock overall. So that seems reasonable. And then you get down into derived measures. If you're familiar with these things, these are called COQ, is cost of quality. So appraisal cost of quality is how long I'm spending reviewing things. And that's an important metric. You shouldn't try and skimp on reviews, is one of the things you'll learn from this. Good reviews take time and should be planned to take time. There is a sweet spot. If you do them too quickly, they're no value. If you take ages to do a review, your productivity is very low, maybe that's not valuable. There is a sweet spot for reviewing things where you get the maximum bang for the buck in reviewing. And it's very interesting to discover where your sweet spot is for reviewing items. It's not the same for everybody. So that's what that cost of quality is telling me. Failure cost of quality is how long it's taking me to rework bugs. That's the cost, that's waste. In a lean terminology, that's my waste cost, and so on and so on. The A to F ratio is that divided by that. That's called the appraisal to failure ratio, is a very interesting number for projects, to look at what it's costing you to review divided by what the failure rate is. So this is the kind of numbers we get out of it. So as I said, you develop 8 programs. Most of them, interestingly, are statistical analysis functions, such as correlation, because they're fairly technology neutral. They're hopefully familiar to people, so they're useful little programs to write. One is an exception. You have to write a line counter program for your programming language. You have to write a program that counts the size of your programs, whatever that size measure may be. Because if you've defined your coding standard, and you've defined a checklist, and you've defined what's a line of code, you then have to write a program to count your programs. And again, that becomes part of your toolkit for the remainder of the course. This building your own tools, thank you, Andy. Building your own tools analogy. When I gave this talk earlier this year, and someone said, oh, it's like metalwork. And I said, huh? What are you talking about? And someone made the point that in traditional engineering disciplines, in things like metalwork apprenticeship or woodwork apprenticeship, one of the first things you do is to make your own tools. If you were, a metalwork apprentice in the 1950s, you had to make test pieces with a file, literally, and milled things, and you made your own tools. You ended up, building a micrometer or something out of from scratch. And this is a very powerful thing because it gives you real in-depth understanding of what the tools are doing and why you should use them and so on. So it's kind of interesting that what you actually end up doing is implementing the statistical analysis that the spreadsheet is automating for you. So you end up understanding what the Excel spreadsheet is doing behind the scenes by actually re-implementing the whole thing in software yourself. It's great fun, I have to say, this course. You actually get to write programs. When was the last time any of you sat down for 5 hours in total silence and just designed and wrote a program? Does anyone have that privilege anymore with no interruptions? Just write a program. It's a wonderful thing to do. Perhaps I'm strange. I don't know. I thought it was a great way of spending an afternoon. But then again, maybe I'm just a nerd with a home computer from the 1980s. I thought staying up writing code was a good thing. Anyway, okay. So for each program, you have to submit data. You have to collect the data. But worse, you have to put it all together and submit it to the examiners or the people teaching the course, and it gets assessed. The examiners actually go through your data and assess that they don't assess that you're more productive than you should be, but they make sure that you really do collect all the data and that you're filling the process properly or following the process properly. So you can't skip and skimp. Process improvement is mandatory. As I said, there's a mandatory post-mortem phase in these efforts, where you have to say, well, I made a mistake there. Look, there's a bug. It cost me, one of the worst bugs I made on the training course cost me 26 minutes to fix and find a particular bug. And for that 26 minutes, I then had to think, well, how could I have prevented that bug? What could I do differently? How could I have prevented that bug earlier, or maybe found it earlier? And that might mean, for example, maybe updating my checklist to say, remember to look for this type of mistake, Rod, you idiot. Don't make that mistake again. But you can't just say, be more careful. You can't make some woolly assertion of process improvement. You actually have to say, do this differently, and make a specific, what people would call a smart assertion of what you're going to do differently. A specific, measurable, I can't remember, attainable, whatever the,